It's great to be back. And who was here in 2003? Who was born in 2003? All right, come on, some hands. All right, because that was the first time I was at Java Polis, so we can honestly say we grew up together, maybe grew old, grew gray a little bit together, but it's fantastic, and it's probably the only event where you speak at where somebody is stealing your show by getting their hair cut. The other thing that is really cool about this event, right, about DevOps is, as speakers, we don't really coordinate much, but we hang out with each other enough that in the end, it all kind of works out. So all the things that Brian just talked about, the complexity being the real cost and management complexity is actually the perfect segue for my talk. So I want to talk a little bit about platforms. Platforms used to be the popular buzzword until Gen AI came along, so now it's the second most popular buzzword. I can live with that, no problem. So when we deal with technology, we always have the vision that sort of, we are the grandmasters of the show, right? Like we push the technology, we decide what happens, we push the technology to its limits, and that's where all the cool stuff and all the cool innovation comes from. But there's an important footnote to this, and that is also the technology pushes ourselves to our limits. The stuff that we cannot easily manage anymore is not going to get widespread adoption. Keyword, complexity. Thank you, Brian, right? The stuff that gets more complex, that has too many moving parts, that will make it hard to deal with it, and that is going to be a major hurdle. So this goes both directions. We push along, but also we find our own limits. And in recent years, we kind of made it worse, right? We had this great insight, correct insight, that the software delivery life cycle has a lot of linear steps and a lot of friction and a lot of handovers between different teams. So I'm like, okay, that is not that great, so what is the easy solution? And that's where great words like shift left came from. Hey, if we shift this all left, you should do all your security testing while you're developing. Hey, you should think about all the operational stuff while you're developing, right? Do this all up front and do this at once. You have tight feedback loops. You don't have all these handovers, and life will be much better. Except now, as an average developer, right, you don't need to be just a coder or object-oriented designer. You also need to be a business analyst. You need to be a security specialist, a distributed system specialist, an operations person. You're expected to be everything. So the next buzzword that we found was cognitive load, and that was sort of a little bit meant to be the excuse for us not being able to deal with all this, right? Which is very obvious. So I call this, we piled things left rather than shifted it left, and now we're stuck with more complexity, and in the end, yes, we are finding our own limits. Now, never short of a solution, right? We have an answer to this, and when I talk with a lot of my customers, right, I get a statement like this, right? So our platform, right, will solve all these problems. It will accelerate the delivery, reduce the cognitive load, abstract away the complexity, yada, 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 right? And Dilbert has fallen a little bit out of favor, but we used to call this buzzword bingo, right? It's like, so it has all the buzzword in it, and the way I described it is a little bit is, this is a hope maker in a way. So, well, this is the foolish optimism, the first stage that Brian talked about, right? But it's also a little bit of the hope maker. We always want to look forward to something that will make our lives easier, because otherwise it's a little bit too depressing, right? There's a lot of stuff, a lot of complexity. So we look at platforms, hey, they're going to get us over the next hump. And the short story is they can, but in a very different way than we mostly think. There's a lot of nuances about what makes a platform work. And one of my common sayings is that as architects, we see more things than other people, right? When we see two boxes on a line, we get really excited and we think about asynchronous messaging and all sorts of other stuff with this. Other people might just say, hey, that's just like two boxes and a line. So what I want to do with you today is kind of take you a little bit on the architect journey and look at platforms and see more when we look at a platform. So Normally, the story starts with let's make a common layer, right? That idea isn't very new, right? We don't need to each write our own JVM. We don't need to write our own language. We don't need to write our own operating systems, right? We have a common layer that does that, and then we sort of do the other things which are less common, right? We do those on top, right? And that is nothing new and largely has worked pretty well for us. When we look at this, though, inside a large organization, right, let's take an enterprise or a government organization, this is largely driven then by scale considerations. It's, hey, I make another business layer for my enterprise, for my business, for my product that I'm building, right? I make another common layer because it's worked so well, right? So another layer cannot hurt. And it's largely driven by scale economics, right? The more people you get to use the common layer, the better the return of investment is. And if this layer doesn't do all the things that it should do, you add to it, right? And that's how we've traditionally built software layers. Platforms are different. They're not driven by scale economics. The scale economics are welcome, right? I only need to do this once, I pay for it once, I use it many times, but they're largely driven by speed economics. I want to speed up development. I want to speed up innovation. I want people to be able to create more new things. And that's an important nuance that will stay with us, right? So here we want broad adoption, but we're also thinking about, hey, if a lot of people use our platform, how good are these abstractions that we've really made, right? Are we at the peak of complexity? I keep citing Brian because this is such a great handover, right? Did we get to the peak of complexity, or did we really arrive at something that is a good abstraction without being an illusion? And the last one is also an important nuance. If somebody needs something, they don't have to wait for us to build it into the platform. They can build it on top. Because that is a common failure mode that we've seen with these software layers inside enterprises, where a team says like, hey, I made the perfect platform for you, and people say this is great, but if you only had X or Y or Z, and then suddenly you have a huge backlog, the team becomes a bottleneck, becomes a victim of its own success in a way, and people start going off doing their own thing because they can't wait for the platform to finally catch up. So you fall back into this, what we call like IT demand management. You file a ticket, take a number, and maybe we'll get to it eventually. All right, platforms, very different, right? You build things on top. And there we see the most important, or the first important fundamental difference, right? The traditional IT model has an assumption that you do the big things first, and then sort of you need to do fewer things on top. And I have a couple of thoughts on this. The first thought is, people stopped building pyramids about 5,000 years ago. So when you draw pyramids into your architecture and IT presentations, you should sort of think twice, right? Why did people stop doing this and we still think this is a fundamental idea? The flaw here is, or the limitation, let's say, which often turns into a flaw, is that the pyramid only works if you can anticipate everybody's needs, because the little tip comes from the fact that people need to do very little for what they need to do because you anticipated everything else. Now that is difficult for two reasons, because A, you would have to be pretty darn clever, right, to sort of anticipate, let's say this is a large bank, insurance company, manufacturing, different countries, different product lines, right? That's the kind of stuff we're looking at. You would have to be pretty darn clever to anticipate each and every person's needs, so they just need to put the little cherry on the complexity cake, right, and they don't have to deal with all this. So that's challenge number one. But even if you manage to be that clever and predict everything, what happens next is that you want change, you want innovation, you want people to have needs that you did not anticipate, because that's what's called innovation. Novum, Latin, new stuff, right? You don't actually want to be able to anticipate everybody's needs because you want people to have ideas that you did not have. And that's the fundamental difference of building a platform. You're not trying to anticipate everybody's use case. You're not making a pyramid. Yes, you're abstracting away things from the base platform, right? That could be the cloud. That's often underneath. This could be CI/CD pipelines, runtimes, many various things, right? Those you want to abstract away. So that's like the bottom half of the pyramid. But on the top, you want diversity. You don't pretend that you've anticipated everything, because you intentionally actually want people to do more things. And you won't believe the amount of hair that's down here. So one thing that we do as software people, though, is that we often believe that we invented everything, right? Because we got all this innovation, we got machine learning and cloud and serverless and all these kind of cool things, right? So we always feel we're at the boundary, right? We're pushing forward. Now, the funny thing is that is often not true, and that is a good thing. You know, I'm a little bit known for using a lot of car metaphors, so we will have quite a few of those. And car manufacturers started making platforms about half a century ago, so in the 70s. So that was before Javapolis started, so a little bit further back. So what they did is have the idea, again, you know, the same idea is it doesn't make sense to build every car from scratch. So why don't I have some common elements, and then on top I just build different models, right? Classic reuse kind of idea, right? Looks like economy of scale, is cheaper to build the engine, transmission, emission systems, do that once, right? And then I can have different models on top. But there is an important nuance, and that's where we can learn a lot about software platforms. The goal here was not to make fewer different cars. The goal was not to constrain. When people talk to me about platforms, they often talk about guardrails, right? We want to constrain. We want to make sure people don't go sort of off the rails here. So they always, they go back into the pyramid in a way. The automotive manufacturers realize that the key power of the platform is being able to make more models, more diversity, right? This started with Toyota and Volkswagen. This is where the Golf, the Jetta, the Passat came from, the Audi A4, different models on essentially the same platform, different customer segments, different price points, right? Different cars, but with common engineering underneath. And if you stick with the automotive story for a little bit, when I was little, BMW had 3 models, right? 3, 5, and 7. I don't have any of those still, right? But very nice cars. But basically, they had 3 models that you could have. A little bit different engine, but that was it. Now BMW has a 1, 2, 3, 4, 5, 6, 7, 8. Then they have an M, 1, 2, 3, 4, 5, 6, 7, maybe 8. I'm not sure. They have an X, 1, 2, 3, 4, 5, and 6. Definitely, I've seen maybe X7, 8. They have a Mini, right? And plus all the other things. So the only reason they can have and each of them has different options, different engines, all that kind of stuff, right? So they're different models, and then they have, you know, variations of each model. They would never be able to have 30 different models without using a platform strategy. So what we learn is here, the goal is more diversity, more innovation, not less. Learning number 1. Learning number 2, in the base platform, you also get more innovation because you have the better scale economics. So if you want to do things like sequential gearboxes, you can amortize that over more different models, and you have a better return on investment. So if you look at cloud platforms, that uses very much the same dynamics, right? All the investments in custom hardware inside the cloud, globally distributed databases, all the data centers, all the global, fiber connections, all that stuff only works because of the scale, because otherwise it's too expensive. So having the scale underneath is a big innovation driver for the cloud base. But on top, well, we have economies of speed. Basically, you are immune to the scale economics inside the cloud, right? You don't care how much it costs to build a data center because you get the server for 50 cents or $1 an hour. Now that is like a magical translation, right? You have the scale economics underneath, and you have the speed, pay per use, right? Do things quickly and only pay as you use on top. So you're disconnected from these things, and each respective side can innovate because they benefit from the platform setup, and that's kind of the double pyramid that we have seen. So with that, I have a simple test, right? We always like to be binary in our world of computer science. I have a binary test, like did you build a platform or not? And here is what I claim is you only build a platform if your users have built something on top that actually surprised you. Right? Because that means you didn't anticipate everything. You give people tools to make more things on top, and that hopefully positively surprised you. Like, take operating systems as an example. Operating systems are great platforms. They're highly standardized. We only use a handful of them these days. But people build things on top that didn't even exist when the operating systems were built, right? Like, basically, large language models were not a thing when Linux was made, right? So obviously, we're positively surprised. People make things that we did not anticipate, and that is good, because that really is the major check mark of building a platform. But it has sort of a footnote to it. It has a nuance to it, right? So platforms aren't really making things for you. They help you make things, right? So you want the people to do stuff on top. So if nobody does anything on top of your platform, the platform isn't very valuable. So it's a little bit of a meta, right? So you need one more step, right? You need people to build other things on top to make this actually function. That's a good way to think about it. You're an enabler as a function. You're enabling other people, but then the other folks still need to go and build those kind of things. And the car manufacturers, coming back to the same analogy, they also learned this, and they learned this the hard way. So the US manufacturers, so in like 80s, late 80s, they had this idea that, hey, this car platform is really clever. So isn't it even more economical, rather than still building different models, I essentially make the same car, I just put a few different options in, and I stick a different label back on the trunk. Right? Isn't that better ROI, because I don't have to make a new body style, I don't have to do all these other things, I just change the name. And that is called badge engineering, right? You just change the badge, and it's largely been a giant failure. There's a car called the Cadillac Cimarron, which is not famous for anything except for the failure that it was, and it's called the Cadillac Cimarron effect, because General Motors had the idea, it's like, hey, the coolest platform I can build, I take a Chevrolet Cavalier, I put all the options in here, power steering, power windows, aircon, all the kind of stuff, I fully equip it, and I now say that is a Cadillac Cimarron. Nobody wanted to buy a Cadillac that is actually a Chevrolet. So, giant failure. What happened here? Remember the pyramid. Basically, what they tried to do is make the top half, right, the diversity part of the platform double pyramid, they shrunk that down. They made the bottom half bigger and bigger and bigger, and they basically fell back into the left-hand model. Nothing was really built on top of the platform, and that deprived the platform of its main value, right? It just tried to anticipate, they tried to anticipate, and in the end, it took all the benefits of being a platform away, because the platform is there for people to have ideas on top, have diversity, have new kind of innovation. So what's on top of the platform is at least as important as what's inside the platform. So if we zoom out a little bit and say, oh, this is pretty cool, right? We can maybe do some new things with platforms they enable without constraining, right? This flexibility, it is very cool. So one exercise I like to do when we come up with a new idea, which we do all the time as tech folks, I always say, why didn't we have this idea like 20 years ago, right? If this is such a good idea, like what was missing? That tends to be a very valuable exercise, because you sort of understand the enablers that made this idea work. And sometimes it's just because we're a little bit smarter, but oftentimes it's because we needed other pieces in place to make this idea viable. So in this context, I often think about one of the most powerful things we can do in tech innovation is removing constraints. We can do things that we couldn't do before. Well, Stefan showed things that, hey, last year we could not do this, right? That's what progress is. That's what innovation is. We can do things that we couldn't do before. And often this comes in the form of opposites, right? And I work a lot with so IT leaders, CIOs, etc., right? And almost everybody lives in the world like this. It's like they have big IT. I used to work in an environment with like 3 billion euros IT budget, right? A lot of money. So what do you want to do? You want to harmonize, standardize, get the cost down, right? So big drive to harmonization. The business at the same time says, hey, competitors are not standing still. The world is moving faster. We want to innovate. We want to have new product. We want to have more speed. So left-hand side, scale economics, right-hand side, speed economics. And the general view is that the two don't match, right? Because standards tell you what you cannot do. Standard says, hey, you can only do this one thing, can't do this other thing, right? So that looks like a constraint. Now, the sad thing about seeing this as one or the other is you'll never be happy, right? Because either you get the cost and the complexity and the diversity down, but then you're slow and you might go out of business, right? Or you have innovation and agility, but it's sort of a crazy mess of random stuff, or maybe a little bit of both. So there is no happy place on this spectrum. So one of the most powerful things that we can do and where platforms play is we can see that things that we thought of being opposites of each other, that we can have both. Quality and speed is a great example, right? It used to be quick and dirty. Why did you have to be dirty to be quick, right? Because the assumption was you couldn't have both, right? But with high levels of automation, CI/CD, automated testing, right? You deliver faster and the quality goes up. Fewer human steps, faster releases, faster feedback cycles, all the stuff we talk about. But if we take one step back and zoom out, what we did is we removed this constraint. We got off this one-dimensional thinking that we can have only one or the other, and we can suddenly have both. And that makes us very happy, right? For me, this is happy progress. You can eat your cake and have it too. You can build good software at high speed. Now, platforms do this along standardization and innovation. Platforms can, I mentioned operating systems, clouds, they're highly standardized things, but they're still huge innovation driver. I used to, until very recently, I worked at AWS on the serverless team, and when there was a little bit of a boring client meeting, I would always tell the customers, hey, listen, the AWS you're buying is the exact same AWS your competitor is buying. And people would go a little bit like, oh, right? Oh, it's like, my God, right? They get the same thing I get. Is this good? It's highly standardized. There's only one product. Replaced with Azure, GCP, and Ali Cloud, whatever, right? Same thing. There's only one thing. But what you do on top, totally up to you. So highly standardized, high rate of innovation. You can have both, and that's the magic of platforms. Customization and cost. Machine learning, e-commerce marketplaces, right? You have a website, every customer sees a slightly different view of it. Costs you next to nothing, but highly customized. We always thought customizing things is very expensive. It doesn't have to be that way. Prototyping, right? They always used to be the curse. If I build something and it's actually good, I have to rebuild it because I need to get it to scale. Serverless largely makes that constraint go away. You can build stuff quickly, and the stuff scales very, very quickly. Sometimes quicker than your wallet, so you need to think about what you build, right? But it does scale, right? So make sure you build something useful, right? Openness and monetization, right? How can you make money from giving stuff away? Well, a lot of the IPOs you see are open source software companies, right? It's like a large proportion, a large percentage of their overall product is out in the open, but people still pay for it, and they're able to have a public offering. So that is progress, and that makes me happy, right? Because we can do things that we thought of as opposites. We can have them both, and that is fantastic. Now, the way this works for platforms, right? I said standards and innovation. Suddenly we can have both, because let's be honest, standards can generally be seen as something that takes choice away. So when I joined a large insurance company many years ago, it was the head of enterprise architecture. I didn't really know what that meant, but it sounded kind of good, and they had nice offices. So I'm like, yeah, sure, I'll do this. So the next thing I found out that the head of enterprise architecture was also the head of standards. And then very soon after, I learned that the head of standards was the most hated person in IT, right? Because your job is, I want to have this database. No, you can only have this. But I need this one, right? Story continues, right? So standards were always seen as being something unpopular. But there's different kind of standards. And here's two examples that work very differently. The one is very old, from 1904. In the city of Baltimore, they had a very large fire, so the whole city burned down. The building codes weren't sort of exactly what they are today, a lot of wood and stuff. So it burned down. What would happen? The firemen from the surrounding cities come to help, but in the end, they just stood around and watched the city burn down. Kind of sad. Why would firemen watch the city burn down? The answer is relatively simple. Their hoses would not fit on Baltimore's fire hydrants. It was not standardized. So since then, there is I think in 1905, they made a Baltimore standard for fire hydrants. And here comes the irony. It was like in the 90s, I think, there were the big Oakland fires, so the West Coast in the US. They still didn't fully standardize all the fire hydrants, and they ran into this problem again. It's like, 100 years later almost. So some success to be had there, but sometimes adoption lags a little bit. But standards here enable you to support unforeseen use cases. Somebody else comes to your town, you can connect, absolutely no problem. Tiny footnote, if you look at these classic US fire hydrants you have up there, they don't have a single size connector. There's two different connectors. So the standard is actually two standards. And some people always think, well, isn't the best standard the one that standardizes everything, like one to rule them all? And the answer is no. You need to understand your architecture. In this case, the architecture is that the firemen have two major use cases. The one is the pump truck, that needs a bigger connector, and the other one is the sprayer hose, which needs a smaller connector. So in the end, that's why there's two connectors, each of them standardized, but it didn't make sense to make a single connector. So you need architecture to have meaningful standards, just like with databases. How many of those do you need? That is an architecture decision. Right-hand one, the metric screw, like M2, M3, this time not the car, right, the screw, right, the little metric screws, highly standardized, allows me to put anything together with everything, right? One of the very first ISO standards that were ratified, the International Standards Organization. So bringing this back to the world of IT, we have a very easy example, right? What has been the most impactful standard that we had in the recent decades? The answer is very easy, HTTP, right? TCP before it, right? Without HTTP, no internet, no cloud, no AI, none of all this cool stuff, right? And it is a very rigid, very well spec'd out standard, but it drove innovation by standardizing the middle. I could have any browser with any web server and any application. Like in the very early days of the browser wars, we almost ran the risk of undoing this, and we're very lucky we didn't. We kept the standard in the middle, and we kept the variability on the outside, right? Again, sort of a little bit the double pyramid, I call it, or sometimes the bone, right? Something is narrow in the middle, standardized, and both ends can vary. So that is the magic of these standards, that they harmonize, but they harmonize things so that I get more innovation in return. Common API standards, same thing. What if I want to write my different services in different programming language, right? Some people like Go, and here's the Rust folks, here's the Java folks, the C# folks, right? How do I get this to work? I standardize the interaction layer. So I call this giving up some options, right? Because I say it's one protocol, this is all JSON, HTTP, OAuth, right? Whatever you have, you give away some options, you lock some things down, but in return, you get more options. And that's the maneuver. You don't standardize to restrict, you standardize to afford more flexibility and more innovation. And that's a very different way of looking at standards. Now, sometimes it's helpful to have a punchy metaphor for this, right? When you talk to people about platforms, my favorite one is A4 paper. It's also a very, very old standard. It's 210 by 297 millimeters in size, and it has this magical property. You put two A4s together, you get A3. You keep doing this, you get A0, and A0 is exactly 1 square meter. Right? I always, making fun of my North American friends. I have to explain this very carefully because, they use letter and legal, and I'm always sure, like, am I allowed to write a letter on a legal paper, or is that not legal, right? I'm always a little confused, right? So for us, this is all very easy, and we can do amazing things. So if you mail a letter and you're wondering how much does the sheet of paper weigh, it is very easy. You buy 80-gram paper, it's an A4 paper, it's 1/16 of a square meter, 2 to the 4th, right? Computer science helps us finally in real life. So it's 1/16, so that sheet of paper weighs 5 grams. Try to do that with reams of 24-pound paper, letter, legal size. You would have to be a lot smarter than me. So these standards are fantastic, but nobody has come and said, I cannot be creative because my paper is A4 size. Right? They say, like, oh, if it was only 220 millimeter, right, I could do this thing, but I cannot because it's only 210. And let's be honest, in IT, we do get these kind of arguments when you build a platform. People come, oh, if it was only slightly different shade of blue on your logo, right, I could use your platform, but sorry, I cannot. Those are the realities of working in large IT organizations. So that's the magic, right? We can have both things. We have standards that actually enable us, and that's the magic of platforms. Now, one thing that we commonly struggle with is when we draw the platform or the platform team in a picture, the picture looks exactly like the old thing, right? There's always like infrastructure and operations, and then there's the people putting applications on top, right? So if you want the simplest picture of how IT works is always a little bit like this. And we all know sort of the little spats in between, throwing stuff over the wall, blame game, right? It's kind of the old story between dev and ops. Now, the platform team, unfortunately, and the platform looks exactly the same. Oh, I have this common platform, and you put the applications on top. And you're like, where's the difference, right? All this magic he just talked about, like, where is it? It looks the same. So the danger here is, well, two dangers. The one is some people actually look at this picture and make the infrastructure and operations team their platform team. And I always say that's a very dangerous maneuver, because on one hand, they're best equipped to make a good platform because they know a lot about the infrastructure and the complexity. So they have the right knowledge, but they have usually 100% the wrong way of working and the wrong attitude, because they're not used to building something to enable developers, to support developers, to drive innovation. They're not used to doing this. So that also makes them at the same time the worst team. So what has happened here? I'm a big fan of models. I always say architects make each other smarter and everybody else smarter by using models. The catch is here we used the wrong model. We used a static model for something dynamic, economies of speed, innovation, change, right? You cannot use a static model to think about things that deal with change, which was our topic for this keynote. So what you need to do, you need to make a dynamic model. How does change happen? What is my inner development loop? What is my outer loop, right? I deploy code. I see how it runs, both technically that it functions, as well as do the users like it, right? I get the feedback from that, and I make it better, or I have new ideas. Now, if you split this across the two different teams, this is where all the friction comes from, right? We know all these games very well. Now, in a platform team, the platform team is not in the cycle. When you do something as a development team, the platform team does nothing at that point in time. And I always give the example, right? I used to work at AWS, right? You deploy a Lambda instance, nobody at AWS does anything at that point in time, right? It would be completely ludicrous, right? So you're not in the cycle, you're sort of the bearing, right? You're the thing that makes the loop go faster. You increase the RPMs, but every time you do something on behalf of the development teams, we're like, hey, I need this resource in a slightly different size. Can you guys do that? Yes, you're kind of happy to help, but you also get sort of a red mark for you back in the cycle, and you cannot afford to be in the cycle because you will slow things down and you will become a bottleneck. So the dynamic model shows this clearly, where the difference is and why the friction is less. Now, have a long list, right? Not going to read this all out, where we basically realize that the difference between sort of a classic IT service and a platform is essentially 180 degrees. They look similar, but they are very different. And that's the stuff I mean when I say as architects we see more, right? We don't just see two boxes. We understand that this is a fundamentally different things. So far, so good. We're riding sort of the elevator down here to the engine room. We want to build one of these amazing platforms. And now the question comes, what does the interface into this platform look like, right? I want to abstract some things away because I want the cognitive load down. I want to support my developers, right? I want to keep them from making silly mistakes. But for that, I need to omit some things, right? Some things got to give. So how do I do that without constraining too much and without building dangerous illusions? So often the naive approach that I see is people take the cloud service and say, hey, this cloud service has a little bit too many settings. So A, that's tough for the developers, and B, maybe some of them, violate my security policy. I always want to have replication. I only want to be in domestic availability zones. Whichever I want to be, I'm like, hey, I'm going to default a few of these settings for you so your cognitive load is reduced and you can develop faster. Unfortunately, it doesn't work very well. And the metaphor I always use, right? If people have a jigsaw puzzle of 1,000 pieces and you say, oh, that's a little difficult, and you take 100 pieces out, you did not make their lives easier. You made their lives significantly harder. And the same thing happens with the cloud. Right now, people said like, hey, why can't I have DynamoDB? Why can't I get this watered down DynamoDB, right? You didn't enable me, right? You took things away, right? And they are correct. And B, the settings that you defaulted impact the way you develop. If you say, hey, replication is on by default, that might mean that if people do not dirty reads. If people do global consistent reads, they will be slower, right? It impacts their performance. And if they always use consistent reads, they're like, oh, why not, right? Everything is nicely consistent. You realize they run into problems, cost and performance problems, because you fix something that you sort of didn't tell them about. So the abstraction does not hold by setting sane defaults. Sane defaults are convenient, but they're not abstractions because they're not really taking things away. You need to understand what these settings were because you make other decisions against that. Right, here's one more car metaphor that shows why abstraction is so difficult, right? There's the old joke, if engineers had named the automobile, right, it would be called the piston, crankshaft, gear, transmission, wheel, assembly, singleton factory, right? That's how we name things because we like all the stuff that we build. We want people to appreciate all the pistons and crankshafts and transmissions and gears and wheels, right? Because that's the kind of stuff we do. So it happens very easily. I caught myself many times naming things after the implementation as opposed to after the purpose. So the first thing that we need to do is when we build platforms, when we need to find those abstractions, right? We need to think about the purpose and the intent. Now, and I'll come to this in just a second. If you think like, oh, this has something to do with domain modeling and DDD and understanding your domain, absolutely 100% correct, right? This is about understanding your technical, or I call it the business technical domain. Understanding that is paramount for building a meaningful platform because, there's patterns by the cloud providers, right? They're called Lambda, SQS Lambda. And they say, oh, this is an abstraction. I'm like, no, this is convenient, but it cannot be an abstraction because if you don't know what Lambda and SQS and Lambda is, right, this thing does nothing for you. It's a convenience, but it cannot be an abstraction because unless you know all the parts, you cannot use the higher level element. So that doesn't work. It doesn't really reduce cognitive load. Maybe it's convenient, but it's not an abstraction. So one test for finding good abstractions is it needs to use a different vocabulary, right? If this thing is called SQS Lambda, right, that is not a different vocabulary. That is piston, crankshaft, gear, wheel assembly. So one more car metaphor. Here's one good example is what is the pedal on the right called? Well, in North America, it's commonly called the gas pedal, and it turns out that is a very poor abstraction. Naming matters, and it's difficult. So the gas pedal, because take the simple example of an electric vehicle. Somebody swapped out the implementation, but left the interface the same. Classic maneuver, we like doing this as architects, but now the name is wrong, because you better have no gas in your electric car batteries. So the proper name, and in UK people mostly call it this, it's the accelerator, it's the purpose. It makes the car go faster, and it doesn't matter whether it's a combustion engine car or an electric car. So focusing on what it's for, not focusing on what it's made from, really helps you find better abstractions. It's just hard because we start with the engine room, so we need to look from the outside in to understand how people actually use it. So the key thing is you need to omit things, and I convene myself here of the very, very convenient word essential. It's sort of like, these are the words like appropriate or essential, right? Do the appropriate thing. You can never be wrong, right? Do the essential, right? So in this case, luckily, it is up to human intelligence largely what you abstract away and what you amplify. Depends on what you're trying to do with your system. If you're in financial services, you probably do different things than when you're in manufacturing. You need to understand your domain. And I would go as far as saying ChatGPT is not going to give you the answer here. It might give you some inputs, but it's largely human judgment to make these kind of abstractions. It's not a token predictor. Good example, right, of having different names. I said operating systems are very successful platforms. And what they didn't do, they didn't fix the drive letter to 0 when you're reading the disk sectors, saying like, oh, same default, right? It's like when you're reading disk sectors, by default you read from disk 0. Isn't that convenient? Yes, maybe, but not an abstraction. Operating systems have higher level abstractions, right? The disk doesn't know anything about files and directories and streams, right? And reading from streams is a great abstraction. Nobody talks about sectors. Every abstraction has a tiny leak and mostly physical leaks. So if you're doing super high performance things on your network or on your disk, you do want to know how big your packets are or how long your sectors are, but that probably happens in like 1% of the cases. Otherwise, you're very happy with the abstraction. But the vocabulary changed. It's not a more convenient sector reader, it is a stream. Get next byte, get next character. So that is a good test for understanding how to make these abstractions. So the tip I give to platform teams is that look for things that the cloud provider could never make. Don't second guess the cloud provider of saying, oh, I have a better DynamoDB, right? What are whichever DB, RDS, whatever, pick anyone, right? What are the odds that you can make a better one? Think about things that the cloud provider cannot make, like saying, I have a database that contains customer data. Because that depends on your line of business, your locale, where you are, your regulatory environment, internal rules and processes. The cloud providers can give you all the dials and settings like encryption at rest, encryption in transit, replication, all these kind of things, customer managed keys, right? They have all these settings, but like Azure, AWS, and GCP are never going to have a cloud product that's called, database that contains customer data for you, dear customer. They cannot, right? But you can. So that is a good way to think about. Make something that they cannot make, and that is a huge leap forward for your platform, right? That, of course, requires you to understand your business technical domain. What does it mean to have customer data? What does it mean to not have customer data? Is it just yes or no, or different gradations? Do you have different security classifications, right? These are all things that come out of your business technical domain. It's a technical thing, it's a database, but it's made on your business domain. So that's the thing you need to understand to make a really good platform. If you don't have this, I would say better not start. So I'm going to finish by giving a few more metaphors. This stuff is reasonably complex, right? It has sort of, twists your brain a tiny bit. So what helps us reason about these kind of platforms is using metaphors. Metaphors translate our decisions into a different domain so we can reason about it much more easily because we know the other domain. So two metaphors I have here. The one is fruit baskets versus fruit salads. What's the difference? You might say both are made from fruit, yes, but a fruit basket really just gives you a collection of fruit, versus a fruit salad is a new product. You can take it on the airplane because you don't need to bring a knife. You can have a better mix of fruit. You can have watermelon and jackfruit in there, which is a little tedious in the fruit basket, right? So there are different things. It enables new use cases, and it's more cohesive. It's like balanced out. So your platform should be more like a fruit salad than a fruit basket. A lot of platforms start with like Jira, Confluence, and Jenkins. That is a good start, but that is clearly fruit basket. As soon as you can make this seem like a more cohesive whole, then you are further off to the fruit salad, and I would consider that a good thing. So if you build platforms, apply the test, right? Did I make enough salad? Some of my friends have said the cloud is really the fruit basket, and then I'm making salad from that basket, and that is a very nice metaphor. You pick and choose and put things together for the next user, and that is abstraction. That is good for platforms. And the second metaphor I have is, as you're building a platform, some of the things you build, the cloud providers may also build. Happened to me. I made like sort of like a CI/CD kind of platform many years back, and then pretty much all the source code control vendors, like the GitHubs and GitLabs, they all have actions, etc. So they all started making CI/CD products, and all the cloud providers have this code commit and code build and what all they call and code catalysts and whatever. All right, they have all this kind of stuff. So I call this being underwater. Like basically the ocean level of base platform rises. In this case, is a positive thing. So the base level goes up, and now you're underwater. And now you need to decide between two things. Are you a submarine, so nobody drowns? Don't worry, right? It's like we're happily submerged, or we need to decide whether we're happily submerged because we built something that the cloud providers also offer. So our scale economics are going to be much worse than theirs. So intellectually, when you build something, people always say, no, I don't want to be submerged, I want to be floating. Right? Because it makes more sense. I shut the old stuff down. I built new cool things in my platform because I no longer need to manage and maintain the stuff that the cloud does. When the time comes, though, everybody gets cold feet, or maybe wet feet in this case, because people say, oh, I need to migrate my users, oh, the sunk cost, all the money I spend building this. So people start second guessing, and that's called having poor decision discipline. So the metaphors can help us say, hey, look, we didn't want to be underwater, so now the cloud provider has built the same thing that we had. So now the logical course of action is we shut that thing down and we use what comes from the provider, or it could be an open source project, right? Something else that has better economics does it for us, so we shut it down. So these metaphors help us in a kind of non-threatening way sharpen our decision discipline. So with that, I only owe you two things. If you wondered about this illusion, yes, this is not, not ChatGPT, or this is not LLM generated. This is actually real. Somebody manufactured this thing, and if you hold it correctly, it does look like an optical illusion. So I felt I owed you the answer to that. And one final piece of advice is, a lot of platform teams go and promise the developers the super highway. They say, oh, I'm going to build this platform. It's going to speed you up. Everything is going to be great. Yeah, there's some guardrails, but don't really worry about it. And what you really delivered is you spend all the money on the guardrails and you had no more budget to put the pavement down. And now the developers are wondering where they're headed with this thing that looks a little bit like a slaughterhouse where you can't go left and right and is not making a lot of progress. So don't be this platform team. So platforms, amazing, cool stuff. They rewrite the laws of physics, right? You can get the speed and harmonization. You can do things that you couldn't do before. So it's well worth doing, but it's not easy. So I encourage you guys, use the mental models, see more as architects so that you can really shape your platform, and then it is well worth the effort. This is a non-commercial conference. We have books for sale, sort of roughly at cost. So basically, if you like this kind of stuff, right, if you want to learn more about platforms, I just written a book about it. So there's an ebook here, QR code. There's a lot of free stuff on architectelevator.com. I always say, luckily, I don't live from selling books, so a lot of free stuff here. If you like a signed printed book, right after this, I'm going to go to the registration desk, and you're able to pick one up. With that, I thank you very much.
Initialize Genesis